This LOS is compare the different weighting methods used in index construction. Price weighting. The simplest method to weight an index, and the one used by Charles Dow to construct the Dow Jones Industrial Average, is price weighting. In price weighting, the weight on each constituent security is determined by dividing its price by the sum of all the prices of the constituent securities. So here we have the beginning of period prices, and here we have the end of period prices. Okay, so we have 5 securities, A, B, C, D, and E. So in this case, it's going to be 1 share each because we're looking at the individual constituent security price. So we have beginning price of 50, 25, 12.50, 10, and 4. We add that up and we get 101.5, and we divide by 5 because there's 5 securities in the index, and we have a beginning value of $20.30. Okay. Over here, we have the beginning of period weightings, but because it's a price weighted index, what we're doing to calculate the index value is just adding up the prices. Okay. But those weightings are important because, as illustrated in this exhibit, security A, which has the highest price, also has the highest weighting, and thus will have the greatest impact on the return of the index. Note how both the price return and the total return of the index are calculated on the basis of the corresponding returns on the constituent securities. Okay, so here we have our ending period prices, so we can see that the price return on A was 10%. It was up from 50 to 55. On security B, ending period price is 22, negative price return of 12%. Security C, ending period price of 8, so that's a negative return of 36. And then D, ending period price of 14, that's a 40% return. And finally E, end of period price 6, 50% return. So what do? We add up all the prices here again and divide by 5, and we have a end of period price of 21. And so we can see, if we just bring up the calculator very quickly again, we'll do 21 divided by 20.3 minus 1 and times by 100, and we're going to get 3.44 as the price return. Okay. Similarly, what they did is they added up the price return in terms of percentages and divided by 5. Price weighting. The simplest method to weight an index, and the one used by Charles Dow to construct the Dow Jones Industrial Average, is price weighting. In price weighting, the weight on each constituent security is determined by dividing its price by the sum of all the prices of the constituent securities. Okay, so we're going to look at this little example that they have in the text. We have securities A, B, C, D, and E, 5 securities. So because we're looking at the price of each individual security, the number of shares equals 5. Okay, so here BOP, that means beginning of period, and EOP is the end of period. Okay, so we can see the beginning of period price for security A, 50, security B, 25, C, 12.50, D, $10, and E, $4. So what we do to calculate the index value is we add up the individual security prices of the constituent securities and divide by the number of shares, which is 5. So we get $20.30. Okay. As we can see here, security A has a market price of $50, which is the highest, and that means it's going to have the greatest impact on the return of the index. So that's an important thing to note with regards to a price-weighted index. The security with the highest price is going to have the biggest impact. Now here we have the ending of period prices for security A, 55, B, 22, C, 8, D, 14, and E, 6. So what we're going to do is add them all up. We get to 105 divided by 5, and we get to 21. So how do we calculate the price return? Well, we're going to do ending minus beginning divided by beginning, and that's how we calculate the return. So I'll just bring up the calculator, or another way that we can do it is just 21 divided by 20.3, and we're going to minus 1 and times by 100 to get a nice round number. And you can see that we have a return. The price return is ending divided by beginning minus 1, or ending minus beginning divided by beginning. We've got 3.45% return on the price return index. Now we're going to look at equal weighting. To construct an equal weighted index from the 5 securities, the index provider allocates 1/5, because there's 5 securities, 20% each, of the value of the index at the beginning of the period to each security. Dividing the value allocated to each security by each security's individual share price determines the number of shares of each security to include in the index. This example assumes a beginning index portfolio value of $10,000. So this is a very key with regards to the equal weighting. You have to have an assumption of a beginning index portfolio value. So there's sometimes a practice question where you're going to use $1,000. In this case, you're going to use $10,000. So let's look through these steps. I have to have that assumption of the $10,000. And also we're going to give the index value a starting value of 1,000. Okay, we've seen that in a previous LOS that we start a index with a beginning value. In this case, it's 1,000. So 10,000 divided by 5 is going to be $2,000 per security. And so, of course, we're starting with an equal beginning of period weight of 20% each. So as the paragraph said, we work our way from right to left here. We have 2,000 market value to each security divided by the beginning of period price, and that's going to give you the number of shares per each security. And you need that because later on when we look at the ending period price, we're going to take those number of shares, multiply it by the ending period price, and we're going to get the market value. Okay? So when we sum up those market values, you can see that we're getting to $11,040. So it's the same data. Beginning prices for securities A, B, C, D, and E haven't changed. 50, 25, 12.50, 10, and 4. We calculated the number of shares, $2,000 each divided by the beginning price. Now we know the ending prices haven't changed, 55, 22, 8, 14, and 6. So the number of shares times the end of period price, we get our market value. So if we bring up our calculator now, we can see 11,040 divided by the 10,000, our beginning price. And so we can see -1 and times 100 to get a nice round number. We have a return of 10.4%. Okay, so then our beginning index value was 1,000. So to get our ending index value, what we can do is we can do 1,000 times 1.104, and we're going to get our ending index value of 1,104. Okay, so the steps to that: step number 1, you have to assume a beginning index portfolio value 10,000. So that's 2,000 per security. Divide by the beginning of period price to get the number of shares. Multiply the number of shares by the ending period price. Add up the values. Ending value divided by beginning minus 1 times 100. That gives you the return. And take our initial index value of 1,000, multiply it by 1 plus the return, and we get our ending index value. So we're just looking at equally weighted. So let's just do a quick practice question here. An analyst gathers the following data for an equally weighted index. We've got 3 securities, A, B, C. We've got the beginning of period price and the number of shares. So for A, beginning period price 20 yen, 300 shares. B, 50 yen and 300 shares. And C, 26 yen and 2,000 shares. Then we have the ending period price and the number of shares. So for A, ending period price 22, still the same number of shares, so I don't need to read that. And ending period price on B of 48, ending period price on C of 30. So calculating the return on the index over the period is A, 4.2%, B, 6.8%, or C, 7.1%. Okay, this question is a little bit tricky because you can see it's giving the following data on an equally weighted index. Actually, we don't need this number of shares here, okay? That's put there as red herring information meant to confuse you, because to calculate the return on the index, and it's a little bit of a tricky question because you can see the beginning period, it's not equally weighted, okay? So you have to make it equally weighted. So in this case, you're going to assume that 1,000 is invested in each security at the beginning of the period. So I'm going to have 1,000 for A, 1,000 for B, 1,000 for C, and I'm going to have a portfolio that's weighted 3,000, okay? Then as we said, we start from our right, work our way back to the left. 1,000 divided by 20, That's going to give us 50 shares of A. 1,000 divided by 50, so at least it's fairly round numbers, is going to give us 20 shares of B. And 1,000 divided by 26 is going to give us a little bit rounding there, 38.46. Okay, so that's step number one. And then step number two, we're going to multiply then that number of shares by the ending price. So 50 times 22, let's just bring up the calculator. Just 1 second here. So 50 times 22, we're going to get 1,100. And this is the way that I would do it in the question as well. Use the space that's provided if they give you a table like this. For the second, it's 20 times 48. So 20 times 48, that's going to give us 960 for B. And then finally for C, we have to do 38.46 shares, multiply by the 30 ending price, and we're going to get I'm just going to bring up the calculator again, 1153.8. Okay, 1153.8. And now I know I need to add the 3 together. So just bring up the calculator. I'm just going to add my 960, and then I'm going to add my 1100, and I'm going to get, one too many zeros. Add the 1100. I'm going to get 3213.8 as my ending, 3213.8. Okay, so then we know how to calculate the return, 3213.8 divided by 3,000 minus 1 times 100, and it's going to give us the answer. So let's just bring up the calculator. So we're just going to divide by my beginning, 3,000 minus 1 times 100, and I've got 7.1266 equals 7.1266, and I want to look what that's closest to. It's closest to C. Okay, so that's how we do the calculation with regards to calculating a equally weighted index. You can see a little bit tricky the first time you do it because they're giving you this number of shares, but we didn't need that to calculate this problem. We had to go through the steps that, making this assumption. That's why I put it in bold there. It's really important. We assumed that 1,000 was invested in each. Divide by the price gives us the number of shares, times it by the ending price, add it all up together, ending divided by beginning, minus 1 times 100, boom, you've got the right answer. So continuing with price weighting and equal weighting, the primary advantage of price weighting is its simplicity. The main disadvantage of price weighting is that it results in arbitrary weights for each security. In particular, stock split in any one security causes an arbitrary changes in the weights of all constituent securities. Like price weighting, the primary advantage of equal weighting is its simplicity. Equal weighting, however, has a number of disadvantages. First, securities that constitute the largest fraction of the target market value are underrepresented. So high market value caps are underrepresented because they're given an equal weighting. And securities that constitute a small fraction of the target market value are overrepresented. So what that means is stocks with a very small market cap are given the same weighting as a company with a big market cap. And that is not an accurate picture of the market 100%. Okay. So second, after the index is constructed and the prices of the constituent securities change, the index is no longer equally weighted. Therefore, maintaining equal weights requires frequent adjustments and rebalancing to the index. So that's a key point. One of the disadvantages of equal weighting is that it requires frequent adjustments and rebalancing. Now we're moving on to market capitalization weighting. In a market capitalization weighting or value weighting, so that's important to understand when they're talking, because you're going to see some questions that talk about value weighting, okay? And maybe I should have put that in bold, but when it's the same thing. Market capitalization, value weighting, same thing, so don't get confused. The weight on each constituent security is determined by dividing its market capitalization by the total market capitalization, which is the sum of the market capitalization, okay, of all securities in the index. market capitalization or value is calculated by multiplying the number of shares outstanding by the market price per share. Well, I think doing the CFA level 1, you should know how to calculate market capitalization. It's the number of shares times the price, okay? So in this case, it's the same table. We've got our beginning of period prices and our ending of period prices, but this column has changed now. We've got the number of shares. So this would be the actual number of shares for each security, okay? So we know how to calculate the market value. It's the number of shares times the market price gives us our market value. So we would add up our beginning values, and we can see we're at $570,500, okay? So the number of shares is not changing, and we have our ending period prices, which hasn't changed. So we'd multiply the number of shares times the ending period of price, and we would get our ending of period market capitalization. So then just bringing up the calculator again, I'll just move it here to the left-hand side. We can see that 579,000 divided by 570,500, and we're just going to minus 1 times our 100, and we get a return of 1.49%. Okay, so you can see a little bit of rounding here, return of 1.49%. So again, with this market capitalization or value weighting, we're going to have a beginning index value of 1,000. So to calculate the value of the index at the end of the period, it would be 1 plus the return. So 1.0149, okay, times by our 1,000 beginning index level. And we'd have an ending index level of 101.4.9, okay? So you can see this key point here is that let's look at this a little bit closely. We had the same 5 securities, okay? They had the same beginning of period price, and we had the same end of period price, but we looked at 3 ways of calculating index returns. We started with the price return, and when we did the price return, we had a 3.45% price return on the price weighted index. The second thing we did was the equal weighted index. Remember, we took the 10,000 divided by 5, 2,000 each, and we had a 10.4% return when the index was calculated as an equal weighted index. And now we're having a 1.49% return on a market cap weighted. So that's an important thing to realize, okay? And so that's it with regards to the market capitalization weighting. Fundamental weighting. Fundamental weighting attempts to address the disadvantages of market capitalization weighting by using measures of a company's size that are independent of its security price to determine the weight on each constituent security. These measures include book value, cash flow, revenues, earnings, dividends, and number of employees. Some fundamental indices use a single measure, such as total dividends, to weight the constituent securities, whereas others combine the weights from several measures to form a composite that is used for weighting. Fundamental weighting, though, can lead to a value tilt. For example, the book value weighted index puts more weight on firms with high book-to-market ratios. And a GDP weights are also used in multi-market indices. A float-adjusted market capitalization weighted index weights each of its constituent securities by its price and A, its trading volume, B, the number of shares outstanding, or C, the number of shares available to the investing public. C is correct. Float is the number of shares available for public trading. Here's an easy practice question to check your understanding. Which of the following index weighting methods is most likely subject to a value tilt? A, equal weighting, B, fundamental weighting, or C, market capitalization weighting? I think you'd be happy to see that question on a test. B is correct. Fundamental weighting leads to indices that have a value tilt. Another quick practice question. Compared to its market value weighted counterpart, a fundamentally weighted index will least likely have A, a value tilt, B, contrarian effect, or C, momentum effect. C is correct. Momentum effect is a characteristic of a market value weighted index, not a fundamentally weighted index. Another quick practice question. Which of the following statements is most accurate with respect to rebalancing and reconstitution of security market indices? A. Equal weighted indices require frequent rebalancing. B. Turnover within an index results from a reconstitution but not from rebalancing. Or C. A price-weighted index requires rebalancing more than a market capitalization weighted index. A is correct. After an equal weighted index is constructed and the prices of constituent securities change, the index is no longer equally weighted. Therefore, maintaining equal weights requires frequent adjustments, rebalancing to the index. And that's the quote exactly from the slide that we saw earlier. Okay? And one last practice question for this LOS. An analyst is creating a new stock market index that is not affected by stock splits. The index the analyst is least likely to develop is A, unweighted, B, price-weighted, or C, value-weighted. I think that was a nice, easy question to end on because the answer is B. If the analyst is creating a stock market index that is not affected by stock splits, least likely to develop a price-weighted index, because we've seen when you have a stock split, the price is going to split in half, and it's going to affect not only that stock but the weightings of all the other stocks in the constituent securities. So a price-weighted index such as the Dow Jones Industrial Average requires adjustment for stock splits. It is computed by summing the prices of individual stocks and dividing by a divisor that is adjusted for stock splits such that the index value is the same before and after the split. Don't worry, we're going to see a question where we have to do those calculations, but in another LOS. And that's the last slide for this LOS. Thank you.